Welcome to the second video. In this video, we are still talking about chemical equilibrium, and I would like to show you how we can solve problems using the equilibrium constant expression, that is the Kc. Now let us consider a chemical equation: nitrogen gas reacting with hydrogen gas to produce ammonia. In this case, our species are nitrogen, hydrogen, and ammonia. Our coefficients are, here is a 1, a coefficient of 1, and here a coefficient of 3, while here a coefficient of 2. Now, how do we write the Kc expression for that? You can see that here is Kc, and as we said last time, the expression is given by the concentration of products to the exponential given by the coefficient. So in this case, our coefficient is 2 and our product is the ammonia. So the concentration of ammonia to the power 2 over the concentration of reactants. So our reactants is nitrogen, concentration of nitrogen to the power 1, so we can ignore it, the 1, and then the concentration of hydrogen to the power 3. Where is the 3 coming from? The 3 is coming from the coefficient here, the coefficient of 3. Let's look at the example. So suppose we react nitrogen gas with 3 hydrogen to give us 2 ammonia, and we find that at 300 degrees Celsius, here given here, the concentration of nitrogen is 0.124 molar. The concentration of hydrogen is 0.372 molar, and the concentration of ammonia is 0.248 molar. Determine Kc for this reaction. So how do we approach this problem? The first thing you need to do is to write down the Kc expression for that. And as we have seen previously, Kc for that is given by the concentration of ammonia squared over the concentration of nitrogen times the concentration of hydrogen to the power 3. So that would be our first step in solving this problem. Now, just rewriting the expression again. Now, the second thing that you need to do is to write down the given concentrations. For instance, here we are saying that nitrogen has a concentration of 0.124, hydrogen has 0.372, and then ammonia has 0.248. These concentrations are given in molars. So what you do here is just simple. You just put the concentration in the Kc expression. Just substitute the concentration for the species in the Kc expression. For example, here we have the concentration of NH3 and here the concentration of NH3 is 0.248. So we just put 0.248 inside here and then square it because of the square given here. You do the same for the concentration of nitrogen here without doing anything to it because the coefficient is 1, and then the concentration of hydrogen and to the power 3 as given here. So when you solve it, just make sure you are very careful when solving these numbers. You find that the Kc in this case is 9.61. One thing that you should take note of about the Kc is that it does not have units. So it may have units, but conventionally chemists made a decision not to have units for Kc. So the Kc does not have any units as shown on this question. So what I would like you to do on your own, I want you to do this problem following the example that we have done. So the problem is, in an experiment conducted at 74 degrees Celsius, the equilibrium concentrations of reactants and products for the equation shown below. So this is our equation. For the equation shown below, where for carbon monoxide 1.2 times 10 to the power -2 molar, Cl2 is 0.054 molar, and the COCl2 is 0.14 molar. So what is the equilibrium expression for this reaction? So what I want to do is to say, all right, Kc is equal to, now you put the species to the power, their coefficients, without the values of the numbers. And then you calculate the value of the equilibrium constant. In this case, now that's when you put in the values. Thank you.